Hello everyone, I am IEI PM Aiden. I want to introduce to you today IEI and the QNAP QIoT Suite 2.0 fully support the OPC UA and how to enter the field of the industrial IoT and automation control to achieve the industrial data collection and centralized virtualization. Today's agenda, we will introduce OPC UA QIoT Suite and how to apply the OPC UA, and finally we will introduce the production application for you. The first, the introduction of the OPC UA. OPC UA is a communication standard of the industrial automation industrial. It is a cross-platform architecture that can be executed on Windows, macOS, Linux, and Unix. OPC UA is a unified access matrix communication standard and security feature with the equation the future. OPC UA is based on next generation technology provided by the OPC Foundation to provide the secure, reliable, and vendor-independent transmission of the raw data and pre-processed information from the manufacturing level to the production plant or the ERP level. This picture shows the system architecture diagram of the OPC UA, including the client and the server of the OPC UA. The bottom layer is the controller that will be used of the production line, such as the PLC and the DCS system, and also the source of the measurement system. The second to last layer is the OPC UA server, responsible for the controlling the production line. The controller receives the data and the value, and goes to the OPC client side. Device can read the data of the OPC server and the utmost measurement system, such as DCS system, control system, SCADA, or the ERP system, so user can understand the working condition of the entire production line. Next, I will introduce you to feature of the QIoT Suite. The QIoT Suite allows user develop and manufacture to easy building the powerful industrial IoT application on QNAP NAS, providing a private cloud, secure and on-premise environment and transforming your NAS into professional industrial IoT platform. We can quickly establish the information system through these three steps. First step will be collection data, like the sensor, machine, device, the development board. The stage 2 will be the data processing. We will use the RAW engine, the through-hole, the trigger, local storage, the data transfer. Stage 3 will be the data virtualization. We will show the detailed data in chart and widget. The QIoT Suite 2.0 component. The software function of the QIoT Suite are RAW engine, dashboard, communication mesh through the HTTP, MQTT, and the COAP, and the OPC UA is an industrial standard communication protocol which can quickly integrate data of the PLC, HMI, SCADA, and other reliable industrial equipment. QIoT also supports mobile phone applications. You can see the status of the production equipment on your mobile phone. QIoT provides a private cloud has user management, device management, rule engine, dashboard, and support the common communication protocol such as MQTT, COAP, HTTP, OPC-UA. The hybrid cloud QIoT supports third-party API. It can easily support other cloud services. For example, data analysis. The control interface like Power BI, it can use B for the data presentation and analysis, and can be connected to the system common used by users. So we will see how to go into the IIoT. What's step? We can see a problem because the PLC server is not enough to provide multiple clients to read and write some at the same time. Now you can join the QNAP NAS as the OPC-UA gateway. You can effectively reduce the delay time, and the PLC don't need to provide multiple client requests, and the traffic control can be generated through the QIoT OPC-UA gateway. Data traffic can get more throughput, provide more connections. The data system, SCADA, HMI, ERP can get production information fast. Latency can be effectively reduced by using QNAP OPC, the QIoT as a buffer. In each OPC-UA client, settings are made for each OPC-UA server, but with the QNAP NAS, we can achieve centralized communication, management, and data storage. So we can see the dimension, more the security and more the capability, and the friendly user, the web UI, multiple user, and provide the management. So we can see the many industrial companies join the OPC the standard. Here we can see the way of the QIoT OPC data stream. The equipment provides sensor data, production equipment data through the QIoT rule engine and the database, analyze and processing, and then to the ERP, HMI, SCADA, MES. Further, the processing equipment production news. Before the QNAP QIoT was employed, we can see that one on-site information communication method is a communicator. Each OPC-UA client needed to set up to connect OPC-UA server twice, and some environment sensor does not support OPC-UA, so HMI SCADA unable to get data. You need connecting the converter to burn in. The benefit of the importing the QIoT, we can have a simpler architecture with the centralized networking management. The QIoT provides a simple UI setting. You can build a good simple architecture. QIoT is responsible for different HMI, SCADA, OPC-UA client requirements. QIoT also supports different communication the methods such as MQTT, HTTP, TCP, UDP, and COAP. Now we will introduce about the easy to deploy, the simple to create, rapidly develop the IIoT. The QIoT should support the OpenCUA server client function, and it can also serve as an IoT value for server and client device, helping companies adopt faster IIoT solution, increasing the business productivity and reducing equipment expenses. What is the take in the OPC terminology? Take a reference to the unique identifier of the data point with an OPC application. Marks real-time data used to reading and write data source. The OPCUA tag. A tag reference a unique identifier for data point with the OPC application. The concept is set as a resource inside a scene, and each scene resource representation a dynamic property data point. The data points can be environmental data, temperature, humidity, brightness, or the industrial relation data, like the machine speed, CPU usage, brand thickness, production yield. We will introduce quickly import the existing case, become the OPCUA client. We will become the client to collection other the OPCUA server, and the management of OPCUA client list use the UI interface. We retrieve and monitor the list tag value in the list status. And the second will be a server. Let other the OPCUA client can connecting our the OPCUA server. We use the UI interface management to easily management of the OPCUA server. So in the UI list, we can easily to management the tag list and user list and the server list of the QIoT OPCUA servers. And now we can be a gateway, so we can making the tag value from the client to server. Just a few steps, so don't need additional learning curve requirement. So we are easy to set up the gateway. Addition to the OPCUA gateway, we also provide a rule engine which allows the adventure development to future process the data before the sending it to the QIoT OPCUA server. Now we will let's introduce about the production application scenario. In this case, about the smart factory, we were connecting the equipment to collect the manufacturer and the equipment data for analysis in order to achieve equipment maintenance, prediction, and machine collection data to ensure the sustainable manufacturing operation and the better management of manufacturing function. Big data is the core of the smart factory, and the collection data in real time is the first step. The PACE 2000 main function support the 8th generation Intel CPU, has the high-speed I/O interface, and support the hard swappable SSDs. It provides the data space requirement by the database and can be applied in smart factory, manufacturing, networking, and AI inference. The Tango AA0 main function support the S generation Intel CPU with the high-speed I/O interface and support the hard swappable SSD. Industrial application can be applied in the smart factory, machine networking, production lines, and machine vision and AI inference. The DRPC330 is a RISC-based system. It has multiple components, and it can be a gateway collecting the production information. So we can see the computers can be responsible for the different level of the task. DRPC330 is the gateway controller. The TAG AA0 is a edge computing server and data virtualization. The PAC 2000 provides data server and management system and the database. In the integration, the IT and OT, we can get the follow benefit: reduce the space use, energy consumed, use less cable and management, e.g. remote operator of the various devices, response quickly to the time, reduce bandwidth consumed, and security employment, reduce the operation expense, reduce data can directly use on the AI and for the equipment maintenance, forecasting, and machine operation. We can see the private cloud and the hybrid cloud and the public cloud have their own dimension. So how to selection is depend on the applying the scenario. In the manufacturing, the QNAP hybrid cloud can quickly and efficiently connecting the OT and the IT. So please contents and follow us. Thank you.